Good afternoon, class. So today we're looking at page 24 and 25 of Unit 5 of Natural Science. So what's a bar magnet? A bar magnet, or bar magnets, are permanent magnets. This means they can't be switched on and off. So permanent means they are always on. They always have a magnetic field. They have two poles, north and south. The north pole is positively charged and the south pole is negatively charged. So the north and the south attract each other. North is always positive and south is always negative. Bar magnets attract metals such as iron, steel, cobalt and nickel. They also attract or repel other magnets. So, attraction and repelling we will look at here. So, magnets and magnetic fields. What does a magnetic field look like? We can see the magnetic field of a bar magnet using iron filings. Okay? We can see the magnetic field of a bar magnet using iron filings. Filings are when the metal has been shaved, so it's almost like powder. Okay, so iron filings is almost like a metal powder. When the iron filings are sprinkled over and around the magnet, they form lines. Okay, in the picture you can see the different lines that are formed. The lines or filings indicate the location and direction of the magnetic field. So if we look closely, we can see that a lot of them are curved. Okay? Just like in the picture, they follow the same pattern. How do we represent magnetic fields? To represent a magnetic field in a diagram, we draw lines. The lines represent the position of the filings we saw in the experiment above. Okay? So they represent the same thing. The arrows on the lines point from the north pole of the magnet to the south pole, as you can see here. There are more lines and they are closer together near the poles because the magnetic field is stronger there. What happens when two magnets attract or repel each other? So without reading, take a moment to look at these pictures and just think to yourself, does this one look like it's attracting or repelling? And same here, does it look like it's attracting or repelling? So in picture A, these magnets are attracting each other. Look at the curved lines at the poles that extend from one magnet to the other. So it says, look at these lines here. These lines represent the attraction between the two magnets. Another clue, remember what we said here, the north pole is positively charged and the south pole is negatively charged. So positive attracts negative. So the north will always be attracted to the south. So here we have north and north. The picture would look the same if it was south and south. If they're both positively charged, they will repel each other. Repel means push apart. Okay? And if it was south and south that were facing each other, they would also repel. So these magnets are repelling each other. Look at the lines at the poles. They don't join up. They turn away from each other. They repel each other. How can we identify a magnet? Think about what magnets attract and what they repel. Magnets attract other magnets and also other substances. Some of these substances may be magnets, but some are not. Magnets repel other magnets, but they don't repel other substances. So we can identify a magnet by testing what it repels. And here I'm sure Sergio will give you some, or has given you some exercises to work on. So what this is saying is that magnets will always attract substances such as these metals, iron, steel, cobalt, and nickel, because these don't have a magnetic charge. But magnets can repel other magnets, as we can see in the picture here, when the same poles, so whether it's north or south, are facing each other, because they repel each other. They do not have an equal magnetic charge as when north and south face each other.